Geometry Standard 9. We're still looking at analyzing transformation. This time in Learning Target 1 and 2, we're going to look at the rotation. So we've looked at translations, the slide, we've looked at the reflection, the flip, and now we're going to look at rotation. We're going to be able to look at how they remain congruent, actually do the rotations, and actually look at the XY coordinates and what happens to them. So we'll get started with some vocabulary here. So our first vocabulary word is rotation. So a rotation, again, is a turn, just like your tires. They turn. So they turn a figure around a fixed point, which means a point that does not move, which is called the center of rotation. It's kind of like I think about a merry-go-round. You know, the middle of that merry-go-round, if somebody was sitting there versus somebody sitting on the outside of that merry-go-round, the person sitting in the middle is going to just turn in that fixed position. They're not going to move. But the person sitting outside of that merry-go-round is going to go around that merry-go-round. And then for our examples, our center of rotation will always be the origin. You can move it throughout the plane, but for simple, we're just going to leave it in the origin, and we're just going to rotate in increments of 90 degrees. So you can rotate in 40 degrees, you can rotate in 235 degrees, but we're just going to rotate in 90. We're also going to rotate clockwise and counter. So if you look at this arrow, this is clockwise versus and counterclockwise. So notice that's going opposite of how a clock would go. And so we don't have to write those words out all the time. We're going to use CW for clockwise, and for counterclockwise, we're going to use CCW. We're also going to rotate in 90 degrees, like I mentioned. So increments. So if this is point P, we'll say point P, and re-rotate point P down here. So we're going to call it P prime. From here to here is 90 degrees clockwise. And then if we put P prime, or I should say P double prime, because we're going to do it twice, we're going to rotate it from here to here. That would be 180 degrees clockwise. And if we go from here up to here to be P triple prime, I think I put one too many, triple prime, this would be 270 degrees clockwise. So again, 90 degrees clockwise, 180 degrees clockwise, and if you add 90 again, that would be 270 degrees clockwise. Pretty hard to read. I'll erase it. We'll go the other way. So if we start with P here, and we put P prime here, and we go counterclockwise, so that's 90 degrees counterclockwise. Here to here, called P double prime. That's 180 degrees counterclockwise. And if we go one more time to P triple prime, right here, that is 270 degrees counterclockwise. So I'm going to erase it one more time. So just for an example of how this works, it doesn't always come out of the first quadrant, but since I gave that example, we'll just leave P here. So if we move P prime here, that could be known as 90 degrees clockwise. So from here to here, and then way from here counterclockwise, that's 270 degrees counterclockwise. So this is probably what I'd write down so that it doesn't get confused with all the arrows. If I put P double prime here, so from P all the way into the third quadrant, so first quadrant to third quadrant, that's 180 degrees. That was clockwise that I just showed you. But if you notice, if you go first quadrant, third quadrant counterclockwise, it's the same thing. So it can be 180 degrees clockwise or 180 degrees counterclockwise. Doesn't matter. And then for our last example, we'll put P triple prime there. So if we go clockwise, that's the whole 270 degrees clockwise. But if we just go from P, so quadrant 1 over to quadrant 2, that's 90 degrees counterclockwise. So notice 180 is the same no matter if you go clockwise or counterclockwise. If you go clockwise 90, that's the same thing as 270 degrees counterclockwise. And then up here, if we go 90 degrees counterclockwise, we go 270 degrees counterclockwise. So we're going to practice looking at those. So here's in quadrant 1. Be sure you notice the prime. Remember, the primes are the image. This is your pre-image. So it comes from quadrant 2 over to quadrant 1. I'll just show the arrow there. So you can go, that would be 90 degrees clockwise. And then if I reverse it to counter, so we're in quadrant 2, quadrant 1 this way, that is 270 degrees counterclockwise. B is my pre-image. B prime is my image. So we'll go clockwise first. So we're here all the way over to quadrant 1. So we're in quadrant 4 to quadrant 1. That was the 270 degrees. If we go the opposite way, so counter, here's B to B prime. Notice I'm only going 90 degrees counter. So here's my pre-image, there's my image. We'll go clockwise. So C went over to C prime. Notice that's from quadrant 3 to quadrant 1. Another way you can look, if it confuses you, look at how much of a circle. Otherwise, you can think about quadrant 90 degrees and then 180 degrees clockwise. If we go backwards or counterclockwise, it's also the same, at 180 degrees. D is my original, D prime is my image. So here's my pre-image to image. So if we start, we'll do clockwise first here, over to there. Went from quadrant 1 to quadrant 2. So we went 90 degrees, 180, 270. And then if we go from D to D prime counterclockwise, there's the 90 degrees. Every time I do this, they should equal up to 360. Oh, back up for a second. I probably said 180, but I put. So go ahead and change that. That's 180 degrees both ways. So we'll go back to E prime. Here's our image, pre-image to image. So E clockwise to E prime is 180 degrees. And then E to E prime counterclockwise is also 180 degrees. And our last example of looking which way, here's F to F prime. So F is in quadrant 2. We're just going to go to quadrant 1. That's just one quadrant over that, which means it's 90 degrees. And counter, we're at quadrant 2, but this time we're going to go this way to quadrant 1. So that's 90, 180, and then the 270 counterclockwise. So hopefully that helps you, because it'll make a difference to what rule you apply to what way you're going, counterclockwise or clockwise. So our next question is that we're going to actually rotate one of these. So we're going to rotate it 90 degrees and then 180 degrees and then 270 degrees clockwise. And we're going to start with this lovely little triangle here. So if I take this triangle, and I'm just going to visualize this. If I go 90 degrees clockwise, so first of all, I'm going to rotate this 90 degrees. And if it's in quadrant 1 and I'm going clockwise, it's going to be down here in quadrant 2. Let me pick it up here. There it goes. So it's actually going to sit right there. Okay, and so we would call that, if we do it right, A prime, and then B prime, and then C prime. I struggle. I can rotate it. I know what quadrant it is, but I struggle on where those points are at. So I'm going to show you, first of all, the rule, the algebraic expression, and then I'm going to teach you how that works, and then we're going to make sure that I actually plotted in the right spot. So a 90-degree clockwise turn, which is also 270 degrees counterclockwise, the rule is, or the algebraic expression is, so let's go x comma y, the originals, which would be all these right here, change to y opposite x. Okay, so in my own words, I'm going to make the x value opposite, and I'm going to take the x and the y values and switch them. So again, let's look at that visually. The x value becomes the opposite, so I made that negative, and then the y value and the x values flip around. So let's look at that up here. So I'm going to change these all to a prime, b prime, and c prime. So x is going to become opposite, and then we're going to flip them. So that'd be 2 to -2, and then flip them. So that'd be 1, -2. X is opposite, so -6, and then flip them. So 1, -6. 4 becomes opposite, and then flip them. So that's 7, -4. So let's go check to see if we put that on the right spot. So it was 1, -2 was a prime, which is where we put it. And then b prime was at 6. I'm sorry, 1, -6. My triangle got a little too big. Should be right here, b prime. And then c should be at 7, -4, which looks pretty good, 7, -4. Okay, so let's look at that triangle again. I'm going to make it very quick here. 1A to B up to C. And this time, though, we're going to rotate it 180 degrees clockwise. So visually, it's just going to go upside down like that. Okay, so that's what it's going to look like. But if we do 180 degrees, if we're in quadrant 1, it's going to come over here to quadrant 3. Let's see if I can get it to pick up here. There it comes. And we're going to put it down here. I think it's going to go right there visually. Okay, so I'll show you the rules, and then we'll see if I rotated that correct. So I went 180 degrees. I know it's in quadrant 1, so I took it down to quadrant 2. I'm sorry, quadrant 3. So I'll go back to the math here. So this time the algebraic rule is, we'll start with x, y, which are all these normal, or the originals. And we're going to just go opposite x, opposite y. No switching, just opposite on both. So in our own words here, x and y values become opposite. Okay, so we're going to put our little arrows here. This time we're going to call them B, A, double prime, B, double prime, C, double prime, because the second time we've moved them. So just make your x and y opposite. We don't have to switch anything. So -2, -1, -6, -1. Opposite 4 is -4. Opposite 7 is -7. Okay. Now we're going to take those points, see if we moved in the right spot. So it was -1, or sorry, -2, -1, which is right there. So that's a double prime. B was supposed to be at -6, -1, which is right there. So that's B double prime. And C is supposed to be at -4, -7. So that's C double prime. Okay, we're going to do it the last time. So again, I'm just going to copy this shape. Okay, and this time we're going to move it 270 degrees clockwise, or if it's easier for you to think about, it's 90 degrees counterclockwise. So here's 90 degrees, so a fourth of a turn, 180 degrees, a full turn, and then a 3/4 of a turn. Okay, or if you want to think of that, if I go back here, the original, it's just 90 degrees counterclockwise. Okay, so I'm going to pick that up. So if it's in quadrant 1, 270 is going to go to quadrant 4 would be 90 degrees. Quadrant 3 would be 180 degrees. So quadrant 2 would be 270. Or again, if you want 90 degrees counter, it's just from quadrant 1 to quadrant 2. So I'm going to pick this up hopefully here. I don't know why this makes it so difficult. There it goes. So it's going to sit here, I think about right there. Again, for me, that's visually hard. I can see it flip, but to know exactly where it sits, I like to use my rule. So we're going to go back to our rules. One last rule here. So the 270 degrees clockwise or the 90 degrees counterclockwise. This time the rule is we're going to start with our XY, of course, and it's going to yield negative, or I'm sorry, opposite of YX. Opposite of YX. So this time the Y value is the opposite. And the X and Y values switch. So yields, yields, yields. This time we're going to go triple prime. This is the third time we've moved these same points. Okay, so the Y becomes opposite, which would be -1, and then flip-flop. So -1, 2. B, -1, the Y becomes opposite, so it's -1, and then flip-flop. 7 is my Y, opposite of 7 is -7, and then flip-flop. Also, I haven't mentioned, but it makes sense. I visually just saw it go from quadrant 1 to quadrant 2. Well, these are all positive, positive. Quadrant 2, the X's are negative, the Y's are positive, which is totally what I came up with. If I visually go back to this one, this is in quadrant 1, it has to go to quadrant 3. Well, I know quadrant 3, every point in there is negative, negative. So notice that works out for me. So if you kind of forget the rule, think about what quadrant you're going to, and then remember which one is going to be the signs, which would help you tell you which one's going to become the opposite. If you go 90 degrees, it was in quadrant 1 and went to quadrant 4. Everything in quadrant 4 is a positive negative. So notice that all my points turned into positive negative. Okay, let's check to see if we put them in the right spot. So A triple prime should be at -1, 2. Whoops, I think I have this turned just a little too much. There you go. So -1, 2, which looks perfect. So that's A triple prime. B triple prime was supposed to be at -1, 6. And then C triple prime is at -7, 4. So I moved it clockwise 90 degrees, 180 degrees, and 270 degrees, or counterclockwise 90 degrees, 180 degrees, and 270 degrees. Okay, so looking at the rules here, so if we use what we know now, so this is our normal XY, so that's in quadrant 1. So I can either visually look at this or look at the rule with it. So if this is in quadrant 1 and that turns into quadrant, well, let's think. It's positive and then negative. Maybe it would help if we make a little thing here. So these are positive, positive. This one is, the X is negative. The Y is positive. This quadrant 4, it's positive, negative. And then quadrant 3 is negative, negative. Okay, so if we know it starts here in quadrant 1, and it's going to get a positive negative, which is in quadrant 4, well, that's a 90 degrees clockwise. So I can visualize that, or I could have looked at the rule. So if it's changing the Y, or I'm sorry, it's flip-flopping, and then it's changing the X, so that'd be Y negative X, which is the 90 degrees clockwise rule. Or if we want to go from starting here counterclockwise, that'd be 270 degrees. Counterclockwise. Okay, again, we can kind of look at spacing here. If this is -4, 5, which would be here in quadrant 2, it's going to a negative quadrant, which is down here. So we can look at clockwise. Quadrant 2 to quadrant 3 would be 270 degrees. I'm sorry, whoop, that was clockwise. Or if we're in quadrant 2 and we're going to negative counterclockwise, that is 90 degrees counterclockwise. The rule is usually what I go with, or the algebraic expression. So I look at it, it's been changed, so it's been flip-flopped. I notice first of all, and then I notice that the y has changed to a negative or the opposite, which then means that's the rule of 270 degrees clockwise or 90 degrees counterclockwise. We'll look at the last one here. Again, you can visualize it. It starts in quadrant 3 and ends in quadrant 1. Okay, that's 180 degrees either counterclockwise or 180 degrees clockwise. So clockwise or the 180 degrees counterclockwise. So again, that rule, here's your x, y. I look at it, notice that it doesn't flip-flop, it just changes to their opposite sign. So the opposite of 6 is 6, the opposite of negative 1 is 1. So that is the rule for 180 degrees. So when we move these, do they change the orientation of the figure? In other words, the way the figure is pointing. So if we go back to, that diagram. So if we're just looking at C, or if you're thinking it's like a table or a couch sitting there in your living room and you move it to here, so 90 degrees clockwise, yes, that definitely would be pointing somewhere else. If this was pointing towards your TV, now C is not pointing towards your TV. So it does change the orientation of your figure. So it changes the orientation of the figure. Does it change the orientation of the vertices, the way the vertices are moving? So if we look at A to B to C, okay, that's counterclockwise. Go here, A to B to C, still counterclockwise. A to B to C is still counterclockwise, and A to B to C is still counterclockwise. So every time I do that, it's still moving the same exact way around. So this preserves. So even though you rotate them into different directions, the orientation of the vertices stay the same. And our last example, so again, this is up to you. If you are really good at visualizing, we're going to go 90 degrees clockwise. So if you can take that shape and turn it 90 degrees clockwise, I know that it's going to end up in this quadrant. I know enough about my rules that I can kind of just look at this and say, well, if it's 2, 1, then I know that if they're going to flip-flop at 90 degrees counterclockwise, so it'll be at 1, 2 instead of 2, 1, and then I know that the signs are going to be positive, negative. If I personally would rather you go ahead and write down all your points here. So we have M at 2, 1, N is at 0, 3, P here is at 5, 2, and Q is at 4, 1. Okay, and that's going to yield here, or change to M prime, N prime, P prime, and Q prime. So I would rather you go through the steps or the rule, but that's up to you. So 90 degrees clockwise, I know it's going to make the y negative. No, I said that wrong. It's going to make the x negative. So it's going to be opposite of the x in this case, and then flip-flop. So it's going to be y opposite of the x. So notice even though I still have to kind of think through it. So -2, opposite of 2 is -2, and then flip-flop. Opposite of 0 is still going to be 0, and so we're just going to flip-flop that. Opposite of 5 is -5, and then flip-flop, or change them around, switch them. And then 4 is -4, and then switch them around. So there's the points. Maybe it's a little easier for you to find them that way. So 1, -2, That's M prime. 3, 0. That's N prime. And then we have 2, -5. That's P prime. And then Q's at 1, 4. That's Q prime. So I'll try to make a straight line. When you do this, though, one thing that I haven't done a good job of mentioning is that when you rotate something, notice it doesn't change size or shape, which means it stays congruent. So when you get done, yours will look much better than mine, but when you get done, this quadrilateral here should look exactly the same. Same size, same shape, remains congruent. So if that visually helps you, if you get done and you're like, oh, that's not the same size, then you did not rotate it correctly. They should be congruent. So looking at, we'll just do these congruency or this corresponding sides here. So MQ, which is that side right there, should correspond with M prime Q prime, and they should be the exact same size. Angle N here we'll mark with the 1 dash here. So that'd be same as, notice, keep your symbols in there. Some of you do not like to leave your symbols in there. You have to keep your symbols in there. So my symbol is angle, and then N prime, and then P we'll make with a double, and then P prime down here should be the same. So notice angle, and then P N prime.